So my name's Reid. I run Charliecloud. One of the things that I always like to emphasize at the beginning is the people. So this is the Charliecloud team, the people who are glowing. That's the current members of the team. There's a lot of us here today. So in addition to myself, we have Megan. Stand up. You're right there. Megan's here. Christian is around somewhere. Yep. And Angelica's here. Good job. Tim is here. The person I forgot was Nick Sly, who is also here. He's from Livermore, I think. He's somewhere. Yeah, there you go in the back. Anyway, so what are you stuck with for 13 minutes? I'm going to talk about why you might want containers in HPC, why you might want Charliecloud specifically. I'll touch real briefly on some of the things that I'm proud of that we've done, and then we'll talk about why HPSF, right? So why do you want containers in HPC specifically? So this is kind of the basic argument for that. What is a container? Well, it's a process or maybe a group of processes that's got its own view of Linux kernel resources somehow, right? Key ones being a file system tree, user IDs and group IDs. It's a key way to bring what we originally pitched as bring your own software stack. Now a lot of it is bring your vendor's software stack. For science applications, the deployment is easier. If you can deploy your application and bring along almost all your dependencies, that makes it easier. The Linux kernel being a big one. libc also comes into play, which we might talk about another time. So somebody asked about ML and AI. A lot of these are showing up just like assuming containerization. We have vendors and they're like, oh, Docker, blah, blah, blah. And we're like, well, we don't have Docker. And then they just stare at us. So the thing that I really like to emphasize is that it's just a process, right? It's more Unix. I've been doing Unix since before most of the people in this room have been born. It's still with us. Whoops. Well, AIML, I already mentioned that. Okay, so what goes into a container? Here are some ingredients. So Linux namespaces, this is how you set up the different views of the kernel resources. You manipulate namespaces there's a variety of system calls. There's also shell tools that you can use to fool around. This is pretty fun. Most of these namespaces are privileged in the sense that in order to create these namespaces, you need root or various capabilities, unless you also add a user namespace, and that lets you create the others in an unprivileged way with various limitations that get interesting, but it lets you do this in an unprivileged way. Now, there's a bunch of other things that you tend to find in container implementations. My view is that the key is these two namespaces, the mount and the user. And the screen doesn't show super well how the others are dimmed out, but that's the key, mount and user. There are lots of container implementations. You just saw another one. I like to think of these and classify them into three types. So one is privileged containers, and this one does not use user namespaces, it just uses mount. And maybe other things, but mount is the key, mount and user. So all the users and groups, that's just the same as the host, right? And some examples of things in their default operating mode, which may be out of date a little bit. So the second one is what I like to call partly unprivileged, type 2, and that is that you have mount and you also have a privileged user namespace, right? So this lets you have arbitrary user and group IDs that are separate from the host. There's some pitfalls. Setup of this is still privileged, right? You can do most of the workflow unprivileged, but you have to set up the user namespaces in a privileged way. And then type 3 is you have a mount namespace and an unprivileged user namespace, right? So the mapping you can create for the IDs is different, or it's more limited, but you can set it up in an unprivileged way, right? So we like this and don't like this. We like this and don't like this, right? Only type 3 containers are fully unprivileged throughout the lifetime. So I like to think about it as a bucket rather than a prison. We use containers for abstraction. You can move between them. I talked about how containers are just processes. Fully unprivileged containers, it's just more Unix, more processes, right? People have thought very hard about this, and just keep doing what you're doing, right? If you have a privileged container, now you have a security boundary that you have to deal with, right? That's hard. So if we come back to the basic argument, why fully unprivileged containers, what I like to call type 3, we're all familiar with the principle of least privilege. And the unprivileged users, it's a very deeply baked assumption in HPC, right? And finally, it works, right? So if it works, why do we need to pay the costs of dealing with additional privilege, right? Now, one detail, which you can learn about more later if you want, running unprivileged containers is pretty straightforward. Building container images in a fully unprivileged way is harder, right? And we'll talk about that. So Charliecloud, what's Charliecloud? It is not this guy. What it is it's a lightweight, fully unprivileged open source container implementation for supercomputers, right? People have a hard time spelling it. It's one word. There's one capital C. And we support the entire container workflow. So we can build images, we can push and pull the registries, we can deal with accelerators, and we'll talk about that a bit more. Importantly, we have, I think, a unique approach to containerization, and we're also remaining compatible where it matters, right? So what's Charliecloud made of? There's sort of three key components. One is the actual runtime. This is a program called chrun. That's a C program. We have chimage, which does all the harder stuff, dealing with other people. And then we have glue, which is shell scripts that do various stuff. Notably, all this is about 9,000 lines of code, which is not very much. If you look at other implementations, none of this is Go, right? So that sort of reaches back to our Unix, how much I love Unix. Possible future components. Angelica's working on a Kubernetes runtime because containers are showing up with that. I personally think Docker Compose looks easier because it's just a YAML thing. So that's future stuff. We developed Charliecloud under this thing that I call the philosophy of Charliecloud. So transparent, not opaque, simple, not complex, unprivileged, right? So what does transparency mean? Containers are regular files and directories, right? And this is true for all the container implementations. It's sometimes hidden, right? Unix does write about a lot of things, and things should be explicit, right? Simple, not complex. Talked about processes, use the minimum namespaces, try to implement the right features, use familiar technology, and embrace Unix. Make each program do one thing well, right? So our thing is running containers. Unprivileged. It's hard to write secure code, so don't. Avoid responsibility, right? So that's one of my favorite things I like to do. So we push it off to existing things. And just a specific example, this is a vulnerability that went around early this year. Because we're fully unprivileged, like the notion of container escape just is not a thing, right? We're another process. So some distinctions versus other implementations. We have the fully unprivileged end-to-end workflow that I talked about. Fully unprivileged run and fully unprivileged build were both industry firsts. We've been doing this since the beginning. We have a small code base that I talked about. Like Apptainer and Singularity CE, we are focusing on supercomputer applications, right? Just as distinct from services, right? And this can reduce your various overheads that can make your life more difficult, right? We're fully independent from other implementations, right? So there's no import Docker that you sometimes, I believe Podman does this, I'm not 100% sure, but like we have our own, we wrote a grammar for Docker files because I couldn't find one. So we use a parser called Lark. Our goal is to balance the traditions of Unix with technical novelty, right? And I think this is going pretty well. I think this approach gives us some opportunities for innovation that I think is very cool. We'll talk about this. And then finally, I see Charliecloud as a public service, right? We're trying to make the world better by having a container implementation, right? So let's talk real briefly about some innovations that I'm proud of. So root emulation, I talked about building can be tricky. So here's a Docker file. We're going to make a couple of special files, right? A pipe, this one is so you can do that unprivileged. A character device, that's a privileged operation. If we build it, it works fine. Notably, we can see that this instruction was perfectly happy, and the way we did it was by ignoring it and doing nothing. And it turns out that HP applications are fine with that. Charliecloud doesn't do layers. We do have a build cache, and it's based on Git. Based on the realization that, like building containers, it's a tree. You start with the root of the empty image, so that's pretty neat. The Kubernetes runtime that's in progress, there's this little thing called a CRI server. That's sort of like the key to it. And then why are we doing HPSF? So why would we join? The goals for us, I'm concerned about project sustainability. This is the best problem. We want to broaden the community. Just like everybody else is saying, we think that we have some neat and unusual ideas. And so that it seems like an opportunity to try and convince people that those are good ideas, or maybe be convinced that they're not good ideas. That would also be successful. Anticipated contributions. I think that the Charliecloud CI/CD is quite good, and so maybe there's some things that we can give back in that regard. What I put down here is weirdness. I think the unusual approach that we take can maybe spark some new ideas. I think it's an opportunity to give back. We've had so much value from the HPC community and the open source community. I'd like to give back. And then the final thing, this is going to sound really sappy, right? But we're stronger together, right? Let's work together and do great things. We do have 2 full Charliecloud days. So we're going to do deep dives into those 3 things I mentioned. There's some more innovations that are happening. SIF, I don't know, read the slide. We have some experience reports. And those are in the Illinois River Room on Wednesday and Thursday. Check the map. We're also doing a Charliecloud training, aka the Charliecloud workshop. And then we also have office hours, which is you can show up and ask questions or tell us how dumb we're being, or whatever. And that's it. This seems like a better slide to end on than my cat, which is next. Oh, here's the cat. Now we're going back. Do we have time for any questions?
Yeah, so let's take some questions. Any questions for Reid? Surely people have questions.
Or other questions.
Oh, yeah. Jonathan has a question. Good.
I have a question. So when it comes to deployment, so you and Aptainer are Charliecloud and Aptainer are distinct from are just separate from the OCI ecosystem, more or less. Mm-hmm. So if I'm trying to package my app in some way that can be used in both scenarios, how would you recommend, what's the recommended way that you would see as being able to do both in the most efficient way possible?
So I think the key there is more or less. So on the more flavor, we can talk to OCI registries, right? So you would push it to Docker Hub or GitLab or whatever, and then Charliecloud can consume that. Is that what you're getting at?
Somewhat. I'm more thinking of image build, right? So if I write a Docker file, and I build a Docker image, right? Mm-hmm. Is that completely can I just take that and run it on Charliecloud and assume it all works, or is there any reason why I should do things differently for a Docker image versus a Charliecloud image and have to build it twice?
Right. There are things that other container implementations are better suited for. In those cases, I think you'd probably pick the other thing as opposed to doing it twice. The key thing might be if your application cares about user and group IDs inside the container, right? So maybe you have a service and part of it wants to run as such, and part of it wants to run as such and such other user. Charliecloud doesn't do that, right? So you need something like Podman or Obtainer or whatever that can do at least a privileged user namespace, and then you can have your processes running inside the container as multiple UIDs. But we can push and pull to registries, so you can build something with Charliecloud and then run it with Docker. However, the user IDs are going to get squashed when you do that. But I think the key is, do you care about user IDs or not? And do you care about actually doing privileged things like listening on privileged ports? Does that answer the question? Okay. Yeah.
I was interested when you mentioned the Docker Compose compatibility that's coming up, because we get a lot of users who arrive with a Docker Compose workflow and want to run it on the cluster. Is that intended to like work within like a batch scheduler job? Like you have a job that, you know, runs a Docker Compose workflow and spins up a bunch of instances and gets them to work together within the scope of a job?
I think the short answer is yes. Charliecloud does not want to do any scheduling. So so I don't actually know Docker Compose really well. I've looked at the YAML and I'm like, this seems way easier than Kubernetes. And then other people have told me that Docker Compose is silly and it's obsolete. And so I don't know, I'm really excited to have this question. So things that happen on the same node or on a single node, that's a process tree. And so we can do that pretty easily, you know, spin up this, spin up that. Things like resiliency and like restarting containers and stuff like that, I don't see that as something that Charliecloud should do, but maybe, I'm not sure. Like one of the things that I worry about is services, like long-running services. You know, like you got your ML model, you want to spin it up. If it dies, you probably want the rest of the job to run, right? That's different from MPI stuff. So that's an issue. Does Docker Compose like specify things to run on multiple nodes?
I don't think we really tell our users. I don't think multi-node would be a priority.
Okay.
You know, it's just running a bunch of services on that node.
Right.
And then when they persist, they just need to be able, because like even a small scope workflow that they get from a vendor, or like even a very small scope workflow, uses services. So it doesn't really need to be multiple nodes. It doesn't need to be resilience. It's just a matter of translating some Docker Compose YAML to something that we run, and you know.
Yeah. I think that roughly summarizes our goal. And I think I've rambled on long enough to answer the question. Okay.
Okay. I think with that, we can move on to SPAC. So let's thank Reid again for taking so many questions. All right.